Hello, this is my coursework to submission for CompExco 3011, a Python command line search tool for HTTPS, quotes, Toscopy, com. It uses requests for HTTP and beautiful soup for HTML parsing, and implements crawling and inverted index with per-page statistics and retrieval. In the next 5 minutes I will demonstrate build, load, print, and find, show multi-word and edge case behavior, explain design choices, run PyTest, show Git history, and finish with a critical generative AI reflection consistent with the green category rules. First, build. This crawls the allowed corpus, pages, constructs the inverted index while processing each page, and saves the entire index to a single file. Data index, GSIN, as permitted by the brief. The coursework requires a politeness window of at least 6 seconds between successive requests. My crawler enforces this by waiting until 6 seconds have elapsed since the previous request completed before issuing the next HTTP GET. On screen I run Python msrcc main build. Because a polite crawl is slow in real time, I may use an honest jump cut within the same recording to the completed terminal output, a time edit only, not fabricated results. Here the tool reports how many pages were indexed and confirms where the GSIN index was written. Next, load reads the saved index from disk, so queries do not require another crawl. Python msrcc main load. Print displays the inverted index entry for one token. For each URL it prints frequency and token positions, satisfying the brief's requirement to store statistics such as frequency and position. Python msrcc main print nonsense. Python msrcc main print good. If the term is absent, the tool states that clearly instead of erroring. Find supports single word and multi-word queries. Multi-word queries are conjunctive. A page must contain all query terms. I implement that by intersecting the URL sets from each term's postings, matching the brief's intent for good and friends. Python msrcc main find indifference. Python msrcc main find good friends. Results are ranked with a simple, explainable score based on combined frequencies and a small span signal between first occurrences, slightly richer than a plain URL list, but still transparent. For edge cases, find with no terms prompts the user to supply a query. Python msrcc main find. A non-existent print target reports that no index entry exists. Python msrcc main print CZZ non-existent token 1 to 3. Search is case insensitive because tokenization, lowercase is text, so good match is good. Python msrcc main find good friends. For the code walkthrough, I use a nested mapping, term to URL, to frequency and positions, serialized to GSIN. That makes print direct and makes conjunctive find a posting intersection problem. The crawler uses a queue-based approach with requests and parses HTML using beautiful soup. A deliberate trade-off is crawl scope. I only in queue. The canonical listing routes the homepage and page end listing URLs to avoid duplicating the same quotes across tag and author pages. That improves efficiency and keeps the index clean. The rationale is in readme.md. Tokenization applies a lowercase regex, so punctuation is stripped predictably, supporting the assignment's case insensitive assumption. For multiple terms I intersect URLs, then rank. For this corpus size the approach is fast enough and easy to reason about. I did not add heavier IR features like tf-if or stemming to stay aligned with the brief and keep behavior easy to defend in assessment. For testing, from the repository route I run Python and PyTest tests queue. I use PyTest with unit tests for the crawler, indexer, and search logic, plus integration style tests for the CLI command, pads and main. Network IORO is mocked so runs are deterministic, without depending on the live site. I cover request exceptions, non-HUML content, types, empty page text, politeness timing via mocked clocks, empty, queries, and conjunctive multi-word retrieval. The emphasis is on meaningful behavioral tests, not only happy pads. For version control, I use Git with incremental commits grouped into coherent milestones, with lightweight prefixage like feat, test, and docs. My commit count is modest, but each commit is intended to be a reviewable slice, rather than one opaque bulk upload. For GenAI, I declare the tools I actually used and for what purposes. Matching my written reflection misleading disclosure would be misconduct. Helpful. Accelerating beautiful soup experiments and mocking requests failures and tests. Harmful. Early bias toward crawling every internal link, duplicating quotes. I restricted scope after inspecting the site. Structure. I treated AI output as entrusted until verified by PyTest and manual CLI runs. Debugging sometimes meant reconciling suggestions with postings fields and argparse wiring, using tracebacks and tests not blind copy-paste. AI saved boilerplate time but did not replace reading documentation or understanding conjunctive retrieval semantics. Thank you. The GitHub README contains installation, usage for all for commands, and how to run the tests.